2.3, finding trig function values using a calculator. So you're only allowed to use a calculator if it says to use one or if it says to approximate, but we'll get through that. Calculator approximations of trigonometric function values, calculator approximations of angle measures, and we're doing in application, literally one application. All right, so when evaluating trigonometric functions of angles given in degree, remember that the calculator must be set in degree mode. Don't worry, I'm going to show you my calculator. We'll go over that in a second and how to get to that. All right, so finding function values with the calculator. Approximate the value of each expression. Because it says to approximate, that tells us we use a calculator. If it does not say to approximate, round, the hundredths place, all of that, you have to give exact answers, fractions. So unless it says approximate or any synonym of that word, you are not allowed to use your calculator. Okay, so I'm going to write down the steps and then I'll actually walk you through those steps. All right, our first step is to press the sign button. Don't worry, I'll walk you through this. Our second step is to input 49. Then we have, so what it'll look like this now, sine 49. So that's where we're at. But we need the little degree symbol. So how do we get the little degree symbol? Remember, we hit second, apps, and then the degree symbol, you'll see it, it's the first one. So you're going to select the degree symbol. So now, after you select that, this is where we're at. So it'll look like this, sine 49 degrees. So now we need the 12. So enter 12. After you input 12, it'll look like this, sine 49 degrees, 12. But we need the little minute mark. So our fifth step for this one is to press second, apps, and it's number 2, so you want to select the little minute mark. So now where we're at, it'll be sine 49 degrees, 12 minutes. You don't have to close it out, but get into the habit of closing it out just in case we have anything to the left or to the right. So close it out. And then our last step is to hit enter. After you hit enter, you should get sine 49 degrees, 12 minutes to be approximately 0.75699505557. It doesn't say how to round. It doesn't say round to this place or anything like that. But we are working with 4 significant digits. So normally we would round to that, but right now we don't know anything about that. So we just keep it at 0.75699505557. Now, let's walk you through that all with our calculator. All right, so with our calculator, we have sine 49. We need to do second apps and do the little degree. Then we have 12 minutes, so second apps number 2. Close out the parentheses, hit enter. There's another way that we can talk about this. There's an alternate way. This, to me, do it that way, it's the easiest. But alternatively, that's a tongue twister for me. So alternatively, we can convert 49 degrees, 12 seconds into decimal. So we could do 49 degrees, and remember for decimal, it'd be 12 over 60 degrees, and we get 49.2 degrees. So what you do in calculator, in degree mode, I have to show you that. I forgot to show you. When your calculator is in degree mode, you're going to input sine 49.2 and just hit enter. So this, you do it the alternate way. If you don't want to do second apps, you could just convert it into decimal. And I forgot to show you how to get to degree mode. I've showed you already before in my videos, but I want to show you again. You hit the mode button and then go over to degree and then press enter after it's highlighted. Second mode will always get you back to the home screen. Alright, B. So we have secant 97.977 degrees. I don't know about you, but if you look at your calculator, secant is not on your calculator. You only have sine, cosine, tangent, and then you have sine -1, cosine -1, tangent -1. But that's not the reciprocal. That means inverse. So that's not reciprocal. Anything to the power of -1, that means inverse. Tangent to the power of -1 means inverse, not reciprocal. So we need to get and use the reciprocal. So secant is not on a calculator, but we know something about secant. Secant theta is the same thing as 1 over cosine theta. So what we're going to do is just flip this to cosine. So we can change this to 1 over cosine 97.977 degrees. And that's all we do. Plug it into your calculator, and we get about negative 7.205879213. So if you're working with secant, cotangent, or cosecant, you just take the reciprocal and then plug it into your calculator. So I'll show you how to do that with your calculator. So we have a fraction, so alpha y equals enter. We have 1 over cosine 97.977. It's in degree mode, so you don't need to put the degree symbol. You only put the degree symbol if you have minutes coming after. And there we go. If you do not have the alpha y equals enter fraction bar, if you don't have that fraction bar, it'll just be 1 divided by parentheses cosine 97.977. And there we go, same answer. Alright, part C, we have 1 over cotangent 51.4283. So cotangent is not on your calculator. It's not. But we know something about cotangent. 1 over cotangent theta is the same thing as tangent theta. So tangent is on the calculator, so let's just take the reciprocal of this to find out our value. So we're going to plug in tangent 51.4283 degrees, and we get approximately 1.253948151. I'm not going to show you that one with your calculator because it's just plugging in tangent 51.4283. Don't forget, it's supposed to be in degree mode. Why is it supposed to be in degree mode? Because we're working with degrees. We have sine negative 246 degrees. There's nothing special we need to do there. It's sine. We have that on your calculator. But you're like, it's negative. Doesn't matter. Okay, so sine negative 246. That's it. Done. 9.135454576. So sine negative 246 degrees is approximately 0.913545546. Alright, now we're going to use the inverse trigonometric functions to find angles. So you know that little blue tangent -1, or sine -1, cosine -1 on your calculator? Now we're going to use them, and we're going to show you why we use them and how we use them. So we're going to use a calculator to find angle theta and the interval of 0 and 90 degrees that satisfies each condition. Now, what mode do we need to be in? We need to be in degree mode. Your calculator should be in degree mode because we're working with degrees. It tells us right here we're working with degrees. So to find the angle that this gives, you just take the inverse because we need to move it over. So it's asking us to find theta, meaning we need to isolate theta. To isolate theta, wouldn't we divide by sine? Except we don't divide by sine. You cannot divide a trigonomic function. What you do to move it over is you take the inverse. So to move it over, we would have theta equals the inverse of sine 0.967709115. So moving it over, you're taking the inverse. Now we can use that little thing on our calculator. So let's do that. We have inverse sine, then that number. So inverse sine is second sine. Then we type in that number, 0.967709115. And we get theta is approximately 75.3999534 degrees. And it needs to be in degree mode because we're asking for theta to be in degree mode. Alrighty, part B, we have secant theta is approximately 1.0545829. So secant is not on the calculator. It's not. So, but we know secant theta is the same thing as 1 over cosine theta. So to plug this into our calculator, we need to do the inverse. We need to move it over. So we need to do the inverse of cosine. And that's going to be 1 over 1.0545829. We put 1 over because secant is not on the calculator. We need to use the reciprocal. So we plug that into our calculator and we get approximately 18.51470,432 degrees. And I'll show you how to do that with our calculator. So with our calculator, we have secant cosine, alpha y equals, enter, 1 over 1.0545829. So one of my biggest cautions, to determine the secant of an angle, we find the reciprocal of the cosine of the angle. To determine an angle with the given secant value, we find the inverse cosine of the reciprocal of the value. So meaning, if you're given cotangent, cosecant, you have to find the reciprocal first. Then you do the inverse. So like we did in part B. That's all that's saying. Alright, the application. I told you an application. That's one answer, or it's one example. 3 parts, but one example. Finding grade resistance. When an automobile travels uphill or downhill on a highway, it experiences a force due to gravity. This force F in pounds is the grade resistance and is modeled by the equation F equals W sine theta, where theta is the grade and W is the weight of the automobile. Calculate F to the nearest 10 pounds for a 2,500 pound car traveling uphill, an uphill grade of 2.5 degrees. Alright, so part A. We know we're going to be using that formula because it's asking us to calculate F. So we need to solve for F. So we have F equals W sine theta. So W is the weight of the car. W, weight, it also tells us. So the weight of the car, so we have W equals 2,500. Then we have theta, which is the grade, and that's 2.5 degrees. So all we do is just plug it in. So we have F equals W, which is 2,500, sine theta, so 2.5. And we'll plug it into our calculator and then we'll round. Alright, so our problem is 2,500 sine 2.5. So I'm going to type it in literally how it works. Now, what mode should we be in? Degree mode. Why? Because we're working with degrees. So we have 2,500 sine 2.5. We get 109.0484684. But it says to round to the nearest 10 pounds. So that's 10, 20, 40, 50, 60 pounds. The next one up would be about 110 pounds. Alright, this is where I want you to pause and try part B. I hope you tried it. So we have F equals the weight. So we have, to calculate to the nearest 10 pound, we have a 5,000 pound truck, and it's traveling downhill with a grade of negative 6.1 degrees. So the weight of the vehicle is 5,000 pounds. So we have 5,000 sine, and then our theta of negative 6.1. All right, you plug it in exactly the way it looks, and we get F is approximately negative 530 pounds. Remember, you round to the nearest 10th of 10 of a pound, so 10, 20, 30, so on. Now, why is it negative? It's negative force, because force is negative. So why is it a negative force? Because the truck is going downhill. So it should be a negative force, right? Because you're going down. How do I know downhill? Well, it tells us down, and it's a negative angle. So why is it a negative force? Because if you're going down, aren't you going to go faster? Because that means gravity is working with you. So the force, it's not working against you, it's working with you. That's why it's negative. Alrighty, part C. Calculate F for theta is 0 degrees and 90 degrees, and do these answers agree with your intuition? So meaning, does it make sense to you? Alright, let's actually calculate these values. So part C. So part C, it wants us to calculate when theta is 0 degrees, and then when theta is 90 degrees. That's all it gives us. It doesn't give us weight. It doesn't give us anything else. So let's plug it into our formula. So we have F equals, we do not have the weight, so W sine theta, which is 0 degrees. Now, sine 0, that's actually 0. You could use your calculator. How do I know you can use your calculator? Because it's a quadrilateral angle, meaning 0, 90, 180, 270, 360. Those are angles perfectly on the x or y axis. So you use your calculator, and we get F equals 0 pounds. Now, does that make sense? It's 0 degrees. So if we're talking about a flat surface, the grade is 0 degrees. So if theta is 0, the vehicle is on level ground, so there's no force. There's nothing pulling you down, or there's nothing stopping you from going up. So there's no force. Why does 0 pounds make sense? Well, this is why. This is why. You're at an angle of 0 degrees. So if you're not going up or going down, there's no force acting against you in that sense. So it does make sense. For our next one, we have F equals W sine 90. Since that's a quadrilateral angle, we can go ahead and plug that to our calculator, and we get F equals 1. We get W1. Because the W didn't go away. Now, does that make sense? How do we know? Because whatever it is, it's going to be weight times 1. So whatever the weight is, that's going to be the force. Here, it was W times 0. That's why it's 0 pound force. But here, the weight is the force. So if your theta is 90 degrees, 90 degrees is a vertical road. So if your theta is 90 degrees, the road is vertical, and the full weight of the vehicle would be pulled downward by gravity, so F equals W. Now that does make sense that F equals W, because the force is the weight if you're going straight up and down. If we go back to part A, we're only going up a hill that's 2.5 degrees incline. That's it. So a 2.5 degree incline would look like just a slow incline, right? So yeah, it's not the full force of the car on you, right? It's only a little bit that's pushing back on the car, right? If we had our car, it's only a little bit pushing back on the car. Same thing for part B. It's a negative, so you're going downhill at 6.1 degrees, so that's a little more, so 6.1 degrees. And we're going downhill, but that's why the force is a negative and it's greater, because it's a bigger downhill degree. But for 90 degrees, your force is your weight because the vehicle is going straight up. So the force is the weight.